Bismillahirrahmanirrahim. In this video, we'll learn about discrete time convolution, and primarily we'll be solving example or discussing example 2.4 solved in the book. So before we start solving of the problem, let's just recall the two formulas, notations given. The convolution of two signals xn and hn is represented by this symbol, and it is equal to yn. So yn is the output and these are the two input signals, or this is the input signal and this is the system response. And mathematically this is represented as yn is equal to summation of signal x and multiplied by the shifted signal h. So we'll see this. Now straight away we come on to the problem 2.4. The two sequences are given here. xn is 1 from n 0 to 4. So you can see from 0 to 4 this has amplitude 1, and at all other places it is 0. So it is 0 otherwise. The other signal is hn. hn is a power n, that is, it is exponentially increasing as the n increases, and it is starting from n0 and ending at n6. So from 0 to 6 it is exponentially increasing, and at all other places it is 0. So first step is to change the variable from n to k. So we change these variables, and we change this because subsequently we use n as a moving variable. Okay, so once we have changed, we get xk and hk. So let's see. So this signal becomes xk and this becomes hk, and the variables becomes k instead of n. Now, so these were the two signals. This was x or this is h. The next step is to flip hk around 0 axis. So flip it around 0 axis. So move it towards the left. So we get this signal, and so its name now changes to h minus k because now we have flipped towards the negative side. The third step is to move the function further left to a point n. So we don't know where is the point n, but we just say that any point n. So we are just moving it to a point n, and so our signal will now be named as h minus k plus n, or we can say h n minus k. Again, if you have difficulty understanding this concept, I would recommend that you must watch my continuous time signal. There also I have tried to explain this, but here I'll also explain this. Okay, so we have flipped and moved it to a point n. So the 0 is now at n. And now the next is that we pull the signal h and k to the right. So we are now pulling it towards the right. Okay, so we are pulling the signal towards right. Now before we go into solving the problem, let me give you some concept of what is called range or interval. So the interval changes when the scenario changes. Okay, now what is the change in scenario? Let's see the first one. For interval n less than 0, so when n is less than 0, that is on this side, there is no overlap between the two, and so we'll say that the output is 0 because output is multiplication of this and this. So this is one scenario, that n is less than 1. What will happen if you pull it further and n becomes equal to 0? Then the overlap starts, and for how long this overlap will move without any change. This one keep on pushing in this signal without any change. Let's see here. So we have moved it, we have crossed 0, we have now near 1 or crossed 1 even. Now if you visualize this, that we are pulling, the moment this crosses 4, when this crosses 4, there will be a change in this scenario, because then this one will be out of this 4. This one will be now coming, let's say n will be coming somewhere and at 5. So this will be one scenario change. So let's see that. So that we'll call interval 2. From n 0 to 4. So n from 0 to 4, there is no scenario change. It is just pushing. But after 4, it will be changed. It will move away or out of this range. So let's see that. And this has now moved out, and this has now come somewhere near 5. And this one, the change in the scenario will continue till what time? Till this crosses 0. When this crosses 0, then on the left side will become now open. So the next limit, we will call it, that interval 3 will be for n greater than 0. So n greater than 4, but n minus 6 less than 0. So till such time n minus 6 is less than 0 or not touching 0, this is one scenario. The moment this touches 0 or it crosses, then this scenario will again change. This was our third interval. We can also say that when n is between 4 and 6. So n is between 4 and 6. This is the third scenario change. And now the fourth scenario change is when n crosses 6, then you can see this has now moved inside xn. So some portion is not covering now. So this is the fourth scenario, and this is for n greater than 6, but n minus 6 less than 4. So this will continue till this crosses this limit. So n minus 6 crosses 4. So this is the fourth interval, and we can write it that n is between 6 and 10. So n is between 6 and somewhere 10. So this will move out of this. So this is the fourth scenario. And now we come to fifth scenario. Now this has moved all the way. It has moved past 10 here. So now there is no overlap. So n minus 6 has passed, n minus 6 has passed 4, or n has passed 10, and now there is no overlap, so output will be 0. So these are the 5 intervals that we'll consider in solving the problem. Okay, so we are in the interval 1, that is for n less than 0. So you can see n is less than 0. There is no overlap, and therefore output is equal to 0. Okay, now we'll move on to the interval 2, and this is how it is looking when we have pulled n inside this box now. So, and we can go up to this point where the same overlap, it is just continuing or pushing in. So for clarity, I have taken two positions. One is n here between, let's say, 1.5, and then the other is n here. So let's see what is the implication of these two. We had discussed this. The limit is from 0 to 4. So the interval is from 0 to 4. I'm mixing the two things. They are two different things. And since when the overlap is occurring, actually we are multiplying a n minus k with 1, and so we can say that the output is a power n minus k, where there is an overlap, and 0 where there is no overlap. Now the main question to understand is how do we get this limit of k? So for this, we'll draw a square box. So this is the square box I'm drawing, showing the overlaps. Now this is the portion which is overlapping, and you can see that we for sure know the starting point from this part is 0. Actually this is slightly error in the drawing. It could exactly start on 0. So we will say that the k is starting at 0, but we don't know where it is ending. We don't know from here, but we know it is ending at n for sure, and so the limit is from 0 to n. Same is true from this diagram. We have moved it a little further, and here also you can see that the starting point is 0. We are not sure from here, but we are sure from here it is 0. And similarly the ending point, we are not sure from here, but we are sure that it is n from here. So that is how you decide the limits. And now it is easy. The range or limit, we are sure that the starting point of overlap is at k is equal to 0, but not sure about the ending point from the first diagram. So we take the ending point from the second diagram, which is n. And here and here. And so now we'll write the summation equation, yn a n minus k, and the limit is from k0 to kn. And now we'll take help of the we'll take help of the finite sum formula to further simplify this. Now the difference here is that this formula is for a power k, whereas we have a n minus k, but we can split it because n is a constant, k is the variable here. So we can write it like this, that this can be written as a n outside, and inside we have a minus k, which can be written as a minus 1 power k. And now we can apply this formula. Just for a we have to write a minus 1. And so applying the formula and then multiplying by an, we can simplify, we get the final result this. Remember, a inverse is 1 over a, and so you can take LCM and then solve. So this was the interval 2 part. Now let's move to interval 3. We have already discussed this, the interval, that now for n greater than 4, so now this has gone out, so there is a situation change, but there is no situation change on this side. It is still outside of the limit. So when will this change? When this comes inside this range. So that means for n minus 6, when it crosses 0, for the time being n minus 6 is less than 0, that is left of 0, and so the limit will be 4 to 6. This 6 you can bring it here, so n will be 6. So this is the interval. And now we can write the equation, because an minus k multiplied by 1 will be an minus k, and 0 otherwise. This is for the overlap. Now here again, how did we get this limit? We draw the box for overlap. So we're drawing the box for the overlap region. So this is the overlap region. Beyond this is 0, and beyond this is 0. So now you can see clearly that the overlap is starting from 0. We are not sure what is this point. So the start point is 0. And we are also sure that end point is 4. But because beyond this is 0, we are not sure what is the value here. So our end point is 4. And so the limit of summation will be k0 to 4, function a and k. And same way, we'll take help of this formula. We take an outside and then we'll solve. So we have taken an outside, remaining is a minus 1 power k. Applying this formula for a, we now just write a minus 1 and then the power same. So this is the final value of yn for interval 3. And similarly for interval 4 we have now moved beyond 6. So for n greater than 6, because now this has come inside the box, and so n minus 6 is now inside the box, but it is still less than 4, because the moment this crosses 4, then there will be no overlap. So it is less than 4, and from here we can write that n is less than 10 by bringing it on the right. So this is our interval, and now we'll find the limit. So this is the value an minus k multiplied by 1 and 0 at other place. Again, the question is how did we get this limit? So we'll follow exactly same procedure. We draw the box. Okay, we have drawn the box. We don't know what is the starting point from the upper graph, but we are for sure, we know that the starting point is n minus 6. So that is the starting point. Ending point, we don't know what is the value here, but we know it cannot go beyond 4. So ending point is 4 from the upper graph. So ending point is 4, and therefore our limit now n k n minus 6 to 4, and this is the signal. And we'll use the formula, but you can see there is a difference. Here the formula is starting from k is equal to 0, but here it is from k n minus 6. So we'll apply a technique what is called shifting of indexes. So for that we want this to be 0, so k n minus 6 to be 0. So we can move it on the left hand side and k minus n plus 6. So moving this on the left hand side, we get 0. Now we want a variable, new variable r, which should also be 0. So we can say that we take a variable r which is equal to 0 and which is equal to this, because this is also equal to 0. So we get r is equal to 0 here. Now what will happen to this n minus k? This will also change. So from here we can find n minus k. So what do? We move this on the left hand side, we move k on the left hand side, so it will be n minus k, and we move r on the right hand side, so it will be 6 minus r. So n minus k will now be replaced by 6 minus r. So here we will replace by 6 minus r. The third question is what will be the change in 4? K is equal to 4. So let's plug in that value. If we, for k is equal to 4, we plug into the equation for r. So plugging in k is equal to 4, we get r is equal to 10 minus n. So 4 will change to 10 minus n. So now let's see the new summation equation. So r0, upper limit 10 minus n, and this has changed to 6 minus 7, and now we can take 6 out. So this is the remaining variable, plugging in this formula, and we get this answer. And finally, when n has moved out, is greater than 4, or n is greater than 10 from here, n is greater than 10, or n minus 6 greater than 4, there is no overlap, so the output is 0. So this concludes our finding out the final values. Now let's summarize. So by summarizing, we can see these were all the values that we got. For n less than 0 was this. For the interval 0 to 4, we had this value. For this, so all these values. And now the question asks us to plot. So we can plot it like this. And I'll just show you but 2 examples. You can take all the values and plot. Remember, a is greater than 1, so I'm taking it, let's say 1.1, and I'm just calculating for this part. So if I take n is equal to 2 and put in here, so a is 1 minus 1.1, n is 2, so 2 plus 1, 3. So if you solve this, you will get y is equal to 2.1. So for n is equal to 2, I can plot here, this will be 2.1. And similarly, for n is equal to 4, same way we put here, and I can find the value 4.64. So this will be 4.64. Same way you can put all the values for n greater than 4 and less than 6, we will use this formula. For n greater than 6 and less than 10, we'll use this formula. So you can calculate all these values if you want, and the plot will be something like this. So I hope this gives you an understanding how to solve this type of a problem. Thank you.